So welcome to this session about Angry Duke, physics-based games in JavaFX. Actually, this talk has been renamed to Angry Nerds because when I submitted the talk at Java 1, after I submitted it, I went to a conference and I met the guys of Atlassian, and they had they had these nice T-shirts here, and they had a mock-up Flash game on their site, on their page. So I went up to them and asked them if I could use that, and if I could use their graphical assets for creating my game. So I'm saving a lot of time with this. And yeah, they said yes, and they're basically sponsoring this talk. So thanks to Atlassian. So is there anyone? My name is Tony Apple, and I'm from Munich. I'm a consultant and trainer, mainly for desktop development and mainly for the NetBeans platform. And yeah, in the last few months, I've been playing a lot with JavaFX. And I'm also on Twitter as Monaco Tony, and I've got my blog on jskills.com. So is there anyone who follows me on Twitter or reads my blog? Okay. You shall not go home empty-handed. Thanks. Okay, for next time you know what that you have to show up. Raise your hand in that case. Okay. So as I said, I'm a trainer and consultant and got a blog, and I'm also a Java Tools community leader, and I'm on the NetBeans Dream Team, so I'm doing a lot of NetBeans stuff. I'm also organizing the J-Day in Munich, so is there anyone from Germany here? Okay. Where are you from? Yeah, okay. But it pays to come down to Munich. December 3, come to the J-Day. I'll give you a free ticket. So this talk is about how you can use Box2D or JBox2D to add physics to your applications, and specifically games. And well, it has been used in many contexts, but it has not been used so often in JavaFX yet. So I don't have to tell you anything about JavaFX, probably. The whole conference is full of talks about JavaFX. Is anyone here already using JavaFX, creating JavaFX applications? Okay. I see a lot of interest, but actually when you ask people who is using it, they're still a little bit, anxious, I guess, to use it in commercial projects. But I saw those great Canoe projects, and I must say that was very impressive in the keynote. So now that it's available in Windows, OS 10 and Linux, and you can develop it in many languages, I think there's nothing that should keep you from developing with it. At least playing with it. So JBox2D is the main part, basically, of this talk, because since you all know JavaFX, at least to some extent, this one might be new to you. JBox2D is a 2D physics engine, so it simulates two-dimensional worlds. It's actually very, very popular. The original project is Box2D, and JBox2D is an almost one-to-one port to the Java world. And you can actually tell that from the user interface, from the APIs. So it really doesn't feel like a Java API sometimes. It's very strange. But I created my own wrappers for most of the methods that I'm working with, so it's much nicer to work like this. JBox2D, Box2D, the original one, has been used in the game Angry Birds, which is very popular. And JBox2D is the Java port, has also been used for the game Angry Birds. I didn't know that first, but the Android version and the version that comes with that you can play in Chrome that is created with GWT, with Google Web Toolkit, is created with JBox2D. So this is really a very nice library that is not just some kind of toy. You can really use it for serious development. If you use JBox2D, the debug rendering, if you create your first worlds, there's a debug renderer, and that is written in Swing. And it also is extensible, so you could actually write your own debug renderers in other UI toolkits, but unfortunately there are some things that really bind it to Swing in the background, so I couldn't use that. I had to create my own stuff. So let's have a look at how Box2D or JBox2D works. The main class that you are dealing with is world. And the world class is created very easily. You create a new world and you give it a vector, a two-dimensional vector that gives you the gravity. It defines the gravity of the world, so it makes sure that the bodies actually fall down. At least most of them. And the bodies that you're dealing with are rigid bodies. That means they are like diamonds. They are not, when you have 2 points, 2 bits on this body, they're always the same distance. So they don't deform. And you create a body by first defining a new body def. That is something that I've, for my own stuff, I've hidden that behind Builder. But if you work with plain JBox2D, you would create a new body def, and you would tell the body what type it is. So this is a dynamic body. There are also static bodies. They are for creating the world, the environment, for example, the ground. And there are kinematic bodies. Those are bodies that are not influenced by the normal forces, but they are moving independent of that. Each body has a position. That's nothing very fancy. A density that makes sure that the body has a mass. It has restitution. Restitution makes it bounce. So the values are from 0 to 1. So 0 means no bouncing. 1 means it really jumps up the whole way again. They've got friction. So when you when they hit some ground or they go down a slope, then they will slow down through friction. They've got an angle, so they rotate when they fly around, which is very nice because this is one of the most important parts of the physics engine. So your bodies like feel natural. You can allow the body to sleep, which means that when the simulation is running and this body has reached some point where it's not influenced by other bodies, there are no forces anymore, then it goes to sleep and it doesn't have to be simulated anymore. Only when a collision happens, the body will wake up again and will be used in the simulation again. There are some other settings like linear damping and angular damping, which is responsible. So if something flows through the air, there's still some kind of slowing it down. You can set fixed rotation. Fixed rotation is important if you have like sprites that are your players and your player sprites, and you don't want them to rotate, but you want them to stand up the whole time. Then you set fixed rotation to true. You can set them as bullets. Bullets means if you really shoot them very fast, then there might be problems with a simulation. They might go through bodies because the discrete simulation steps might send them through a wall, and that's not what you want. So this starts continuous collision detection. You can define that the body is inactive, which means Active is the default. If it's inactive, this means it's asleep, but you cannot wake it up. So that is if you want to park a character, for example, a sprite, and it should not collide with any other stuff until it's active, like in Angry Birds, the birds that are sitting there and waiting for their turn. And you have user data. And user data is the payload that you can put in. And in some of the tutorials that you've maybe seen in the internet for using Box2D together with JavaFX, they put a node in there, which is nice, which is a good thing. I'm not doing it like that. And I'll tell you later why. And yeah, when you're ready, when you have defined all of that, you simply let your world create your body. So that is the first important step. The next thing that you're dealing with is shapes. So the body itself only has a position, you saw that, it doesn't have a shape. So the shapes are independent of that, and the shapes actually don't know to which body they belong. They are reused in different calculations, obviously, so that is the reason why the shapes are actually don't know anything about the body, and the body itself doesn't know about the shape directly. There are three important ones. That's circle shape, polygon shape, and chain shape. Chain shape is used for creating like the environment. That is really cool. There's also edge shape. I'm not sure why it is missing here. Maybe it's because my presentation crashed when I connected it to the beamer here. But well, those are the most important ones. The chain shape consists of edges, interconnected edges, and those edges can be used to make the terrain of your game. So I'll talk about them in more detail. So the first shape that is the circle shape. The shapes are important for calculating the collisions, and they are used to compute the body mass. So you take the shape and the density of the body to calculate the body mass. You can do raycasts with them, and you can test the point if it overlaps. The circle shape is very simple. It just has a position that is relative to the position of the body, and it has a radius. That's what you would accept from a shape, right? The polygon shape is a solid and convex body, and the points here must be defined in counterclockwise order. It's a bit. That's also something that is a bit strange about the API, that the system itself doesn't test when you create a new polygon if you really define it in counterclockwise, and it doesn't throw a warning or so. So you have to really be careful what you do. It does also not test if your body is actually convex, and if you create something like this, the system won't complain. It will just not work very well. So like, for example, if you create polygons clockwise, then bodies will stick together when they collide, or something like that. That is an indication that you did something wrong. So the polygon shape is also very simple. You have this array of vectors, and you can set them. You also have a count here, and the count means which of those vectors you want to actually use. So you can have you can define 8 vectors and only use 3 of them. I don't know why that is. It's just the way it is. Okay, here I've got something about edge shape, the missing edge shape. Edge shapes are specials in that they have no volume, and they are mostly used for creating the terrain. And they've got basically 2 vectors, and they are connected together. Edge shapes are something that is used in the current version of JBox2D. They already have implemented chain shapes, but they are not in the official version, in the official release. I'm still using them, and they work fine. And they've got a benefit, because those, if you put edges together, to a larger shape, you can have some kind of ghost collisions here. So if a body slides here, you get a collision when it hits the corner here, and that is something unwanted because this collision is going to be reported, and you don't want that. So it's better to use the chain shape. The chain shape takes care of this problem. So if you are gutsy and you want to use the development version, you can use this. Also, the chain shape, like the polygon, has a couple of vertices, and you can either create a chain, which means shape like this, or you can create a loop, which means the system will close this like in a polygon. I'm not using it in the Angry Nerds game, but I also created a pinball game. I don't know if you can see it on YouTube. I made some videos with it, but right now I've rewritten the whole engine, so it doesn't run. I cannot show it to you. Fixtures. So I told you that there's a body and there's a shape, and they don't know each other directly, but in order to attach a shape to a body, you create a fixture. It's important to know that a body can have more than one shape, so you can have rather complex bodies, and that is something very typical. But in my examples, I'm only using a one-by-one mapping to make it simple. So to create a fixture, again, you have to have a fixture dev. You create your shape and set it on the fixture dev, and use the body to create the fixture with the data that comes in from the fixture dev. And that's it. Now you've got your first bodies, and you actually can run. So the next step is to start the simulation. Box2D simulates those of all those physics equations. Newton basically is running and calculating in the background at discrete time steps, which means that you have to tune your system for the correct value. Well, usually when I'm using it, I'm using 60 Hertz basically, and that works quite well. So, like, this is a simple example. We create a new world, and we create a new time step here, and we walk through this. I'm just looping here. Usually you have like an infinite loop, but just for the sake of testing, I started like this, and then I step through the world. You call the method step with the time step. And you also have two values for defining how many iterations are used for velocity and position iteration. So when the velocity and positions are calculated the higher the value is, the more accurate the calculation actually is. 8 and 2 is, I think, a very good value that you can work with. So we can now do a little hello world. At least I hope so. Let me check. And to do that, I create a new Java application. Okay. And I need to have a couple of libraries. So obviously I need JBox2D. And I also need some logging framework that they require. Okay. So let's create a new world. Oh, by the way, you probably can't read that, right? So tell me when I'm when it's okay for you. Like this? Okay? Okay. So I'm creating a new world. And this is a typical value that you can use. So what's wrong here? Okay. So the error here was actually some feature that I added to the JBox2D, which is I created a XML persistence format for it. So I want to be able to edit JBox2D worlds, and I want to store them and reuse them as levels. So I created this format, and this is also in the library, so I used the wrong ones. I imported the wrong ones. So these are the ones we need. Or JBox2D Dynamics World. Do a time step. And we do the loop. Let's do 100 iterations. And we create a body. So I'm not doing it like I've just shown it, but I'm using builders for that. So here's a circle shape builder I created. I actually always mix up the builders from JavaFX with my own ones. And in the builders from JavaFX you say like circle shape builder create, and with my builders you have to say new circle shape builder. Okay. So we want to set the position. Let's say this one is at position x5 and y 10. Give it a density. What else do we give it? Radius. We have to set the type. We want the dynamic body because we want to see how it's simulated. That should be it. Build. So here's my circle. I can say world step. Time step 8, 2. And I'll simply ask my circle for its position. And print that out. So this is probably going to be very hard to see here. Maybe I can set the default font so you can see something. Otherwise it's going to be boring. Fonts and colors. I don't know if the output picks that up. I'm sorry. You will have to believe me what I tell you. Okay, so I simulated it, and you can see here the body position. The X position stays the same, but the body falls down. So here we're already at 0. Not yet. I have to add a couple more cycles to the loop. Okay, and I will add a second body, a static body that it can collide with. So new box builder, type static, position, I will position it just below the bodies. That means also at position 5, 0. And I set the height to something small, and I make it like 10 meters long. Actually, we're dealing with meters here, so you're not talking about pixels, because this is just simulation. These are meters, and the bodies that you create should be between 10 centimeters and 1 meter in size. Otherwise, they are not very well between 10 meters and 10 centimeters in size. Otherwise, the simulation doesn't work so nicely. Okay. Anything else we need to do? Type is set, so that should be it. Okay. Let's again do a simulation. Okay, so we see the body comes to a halt. It stays here because we didn't set restitution on it, and we can do that as well. So make it bouncy. And what maybe some guys in the front row can see is, no, it doesn't actually bounce yet. Oh, yes, it does. It does. Like here, it bounces up again. So the values get bigger. Yes. JBox2D doesn't do anything else but simulate a world. So it doesn't do anything fancy. It doesn't do graphics. For the graphics, you have different debug renderers, or you can create your own rendering. So I've created a NetBeans plugin. That's work in progress. Don't use it for anything but playing around with it. But I want to show it anyway. Maybe I can get somebody interested in helping with it. So this is JBox2D support. The interesting stuff about this is that I'm using my persistence format there. So you can create a new file. And in this file, you will have your bodies. You can drag them around, and you can simulate them. So I don't have it open. Let's check where it is. We won't open the required projects. So what I'm doing here is I'm using the visual library from NetBeans to visualize the bodies, and I'm using the default debug renderer from Box2D to render the results and simulate them. So let me create a new world for you. Okay, here we've got the world. And we already have a body here. We can simulate that. So it falls down. Also not very fancy yet. We can add in more stuff, like a static box. As I said, this is not very polished, so JBox2D Box2D support it is called. Sorry, it's a yeah, it's a plugin. It's not, you cannot install it. You really have to build it, because I don't make a plugin from this because it will probably crash at some point. Your IDE, it's still work in progress. So it's basically work. It's my it will be my world editor. So you can add complex bodies and create your own bodies. This one here is, for example, Strand Beast. I don't know if you know Strand Beasts. There's some crazy guy in the Netherlands who creates these huge structures that are actually only moved by wind, and they look like they are actual animals or something. So, and this is a simulation of a Strand Beast. Whoa! I guess I'll have to move that. So that's not a Box2D problem, but a Tony Apple problem. Okay, so and you can see you have like these revolution here, these motors that you can define, and they really act very cool. I really enjoyed that kind of stuff. So if you're interested in something like that, in helping me, and you want to learn a little bit of about NetBeans, just contact me after the talk, and we can maybe make you a committer or something, or a tester. Okay. So what we've seen here was the debug renderer from JBox2D. It's implemented in Swing. And it also enables you, as I've said before, to create your alternative implementations. But problem is the event model is EDT thread, AWT event model, and it's a canvas-based rendering concept. And well, we have canvas now in JavaFX, but you don't want to use it for that, because we're programming with nodes. We want to have nodes, and we want to move the nodes around. But what the debug renderer gives you is some vectors that you can draw on a canvas. So you don't find out anything about the nodes themselves. You cannot reuse them. So that's another way to go. So you have to create your own rendering if you want to do that. And in order to do that, you have to know how the Box2D worlds look. And the Box2D worlds look like this. You've got a coordinate system, and the bodies can live in each of the quadrants. And they do that because the physics engine sends them there. So, as I said, the bodies should be not bigger than 10 meters and not smaller than 10 centimeters. Problem with this is that the y-axis is positive, is pointing, because it's natural. Well, this is up. So this is 10 meters, or this is not 10 meters, this is 2 meters and 50 maybe. And bodies should fall to the ground, so it's natural to program like that. So it's natural that they have this kind of coordinate system, but that is a little bit of a problem if you want to render it, because when you do it one by one, and you just define your bodies big enough and want to translate everything will be upside down. So you have to do some kind of mapping. And there's even more of a problem when you bring everything to the screen. It will be not sized very nicely, because those things are like 10 pixels if you just scale them 1 to 1, and your screen is maybe 1,000 pixels. So, to speak with my favorite Little Britain character, computer says no. I don't know if you know Little Britain here. Anyone? Okay. I should not use this in the States then. Okay, but what you can do is, like, you can first off flip the y-axis and do some simple scaling. You set the meter to pixel ratio, and you set an offset, so you really move the bodies where they can be seen, where they can be displayed in the screen. And you calculate your screen positions like this. And maybe you wonder why I'm doing that, because JavaFX can actually do transformations, affine transformations very easily. I used that in my first effort, and it worked pretty well. But after a while, you get lost, because it's very hard to find out where the objects are actually on screen. And if you want to do things like follow body around, and for example, in Angry Birds, if you launch a bird, it flies, and the camera follows it, so you can see what it actually does. And if you want to do stuff like that, it's very, very hard if you do the transformations. So it's a good idea to actually put those nodes where they should be displayed on screen. Then it's much easier. My brain was about to explode when I did that kind of stuff, because it was so hard. I was drawing diagrams, and I was dealing with the 3 layout bounds that JavaFX has, and it really was very hard. So the basic calculation is this: you translate it, and you set your meter to pixel ratio. It's very if you do that kind of stuff, it's very useful to have a camera class that does the conversion for you. So when you really want to place the bodies, and you ask the bodies for their position or for their rotation and stuff, you can simply use the values from convert world to scene and pass in the camera to the providers that actually create your nodes and that actually place your nodes or locate them on screen. So I created that in a project. And this was the first problem that you need to solve if you do something like that. The second problem is with the canvas-based rendering concept. So what I want to do when I do JavaFX rendering, I want to create nodes, and I want to display them on screen, and I want to reuse them. I do not want to create a scene with hundreds of nodes every 60th of a second. So I need some kind of map. And that is one approach. So I can, in each step, when I'm called and I'm asked to render the world, actually, when I'm rendering, I can look for the body. That I get the body from the world, and for each of the body, I look up the node that corresponds to it in the map and place it where it should appear according to the simulation. That is one approach. The other approach that you see very often on the internet is you put the node into the body, as you saw that in the beginning. Each body has a slot, basically, where you can put your own custom objects. You can put anything in there, and a lot of people are doing that. I'm not doing that, because what I created was a debug renderer. And with my debug renderer, I want to simulate worlds. And if you, for example, create a world or created a world before, and you want to simulate it with my renderer, I cannot force you to put nodes in there, but you can put anything in there. So I created a map, and whenever I get a body, I look it up, and if it's already there, if it's not there, I ask for a provider that gives me the node, that produces the node for me, and that can configure it with the new positions. So that is the approach that is better for if you want to do something generic. If you want to have some generic rendering and not something specific. If you want to do something specific later on and you create your game or whatever, then you can go with the concept of putting the nodes actually into the body. That's easier. So in each step that we've just seen, you can call a method, and in this method you loop through the bodies. So this is how I'm doing it. I ask the body for its user data. No, this is basically the other approach. Sorry. This is the approach where you use the body to store the actual node. And then you can configure it accordingly. You just get it from the node, you configure it, and you display it on screen. I'm not doing it like that in my project, which is also on GitHub, and it's called JavaFX Box2D. I uploaded it today, so if you want to play around with it, it's a couple of probably like 200 lines of code, maybe a little bit more, and it gives you a very nice idea what you can do. Very simple examples. And I will show you how it works. So I've got it here. As you can see, this is all there is to it. We've got this world view. That's the most important thing. It takes the world as a parameter and displays it. There's the camera class. It's extremely simple. World metrics will disappear soon, and we've got a node manager. And the node manager actually gives you is responsible for providing the nodes for the bodies. So you can use the node manager to and ask it for a node provider, and the node provider will give you a node for your body. And you can register your own providers. That is what I'm doing, and in my Angry Nerds game. And there are a couple of predefined providers that you can look at. They are not very elaborate, and they will be improved soon. But for some basic stuff, they are sufficient. And I've created an empty JavaFX application to show you how to use it. So we will again use the world that we've just created. I'll simply copy it over. Okay, so this is what I've just created, and now I'll create a world view. I'll give it a size that is actually not. I think it's not even necessary anymore, but still, this is work in progress. So I'll create a new scene. Also 800 by 500. And I'll tell the primary stage to display this scene. And I show the primary stage. Show it is, I think. Okay. And I start the simulation. Okay. Nothing happening yet. Actually, don't need this because the worldview is doing the simulation itself. And that is because I haven't translated it yet. So I get the camera and configure it. Like 50, that's the meter to pixel ratio. And I need to translate it by a vector. And for this, I'm going to, let me see where our bodies are. They're at, okay, they start at 0 and 10. So here we can see our bouncy body. Still not very fancy, but you can see how that kind of simulation is supposed to work. So the most important class inside this project is the worldview, and the most important method is the method that actually does the simulation. And for this I'm using timeline. Timeline is a JavaFX class that you can use to time events. And I set the cycle count to indefinite. Duration is 1 by 60. That is the time step that I'm using actually here. This. And I add a handler that it should be called on every whenever the timeline, whenever the keyframe is through, and in each of these steps, events, I call a world step. That is basically the loop, the game loop. So here the simulation is started, and after I simulated it, I update the bodies. I call a method to update the bodies and relocate the objects on the screen. And in the update bodies method, I ask the system, I ask the world for the body list. Well, as a Java guy, I had expected to get a list or a collection here, but since it's a one-by-one translation of box to D, what you get is a body, and this body is linked to the next body. So I loop through it like this. Well, next body not is null, next body is next body, get next. But the more important part is I then get the shape from the body, and I ask the node manager to give me a node provider, and this node provider is the class that actually can configure my node, that knows what my node is for, how my node should be displayed. And I pass in the body and the shape as a parameter, and the node provider will then the node manager will loop through its node providers to the registered one and will ask each of them, can you create a node for this body? And if there's no node manager that you registered, no node provider that you registered, it will give you a default renderer for if it's a polygon, there's the default polygon node provider. If it's a circle, the default circle provider. And then you ask this node provider to configure your node, which means relocate it and scale it and maybe rotate it. And if we do not have this node in our map, we add it. So we add it to a map. So next time we can look up the node in order to configure it. So we do not have to create. We just have to create the node once in the first run through the loop. This is how the node provider interface looks. It has this configure node method and the provides node for method. This is what you need to implement to say, like, if based on the user data that is in the body, for example, I can provide a node for this body. So if I, for example, if I create the Angry Nerds game, there's the bird, and I register a bird provider, and the bird provider says, yes, I can provide a node for this body if the user data is a string bird. Here's the implementation of one of these providers. So it's very simple, actually. You just use if the node is if you don't get a null passed in here, you have to create the node, and if you have the node, you have to configure it. And you use the you can use the camera to convert the coordinates of the body. So, for example, the position. And you can also use the camera to scale your body. In that case, you scale the radius. And then the node will be added to the world view, if it's not already a children of the world view, and it will be displayed on screen. So, for this, I have created a little game that builds on top of it, and that is still called Angry Duke. And I will run it first, and then I will show you how it works and how you can extend it. So you've got these different levels here. Just a second. I will first show you the result. This was the empty level that we are going to. So first you see something here, you see the enemies, and then I'm using transitions to actually move the world around, and you can see our node here, our nerd, our angry nerd. And here's one of the enemies flying around in the air. This is already simulated by Box2D. It's actually not flying, it's dangling on a rope. And these are the node, I'm using the node providers that are in the project on GitHub. So you can reuse these. This guy here is not simulated by Box2D. This is a regular JavaFX node. It's actually two nodes. So this is the chair, the Aaron node, because this chair I learned is called an Aaron. And this is just image view. And I use a couple of transitions and combine them to make this effect. So the first one is a translation. Then when it's up here, there's a rotation. And when it's down again, I make a pause or two pauses, and then I switch the image, which makes it blink. It's very simple. It's like, I can show you. It's a couple of lines of code. So here's the animation. So first we have the translate transition. We have these interpolators that make the transition soften when it reaches the end and when it starts. So it's really like it starts slowly, then it goes faster, and then it slows down. And I've got the rotate transition. I've got a translate transition that brings it down again. And I've got a custom animation, which is a custom transition, where it's probably there are better ways of doing this, and the JavaFX experts will probably tell me that this is not the right way to do it, but I'm simply switching the image here. And JavaFX allows you to create parallel transitions and sequential transitions. I first, this you can see from the code that this used to be actually a parallel transition in the beginning, but I found out that the blinking is better when it happens at the end. So this is actually I shall rename this now, so, because it's probably a little bit. Okay, so it's actually a sequential transition, and this is the important part of the sequential transition. You have this add all method, and here you can add all of your transitions. And I will show you the first one that I add in here is a pause transition. Then we have the animation that makes it blink. Then we have another pause. 500 milliseconds, then we again let it blink, then we translate it, make it jump up, we rotate it when it's on top, and we start another translation to move it down again. Yes?
Just a quick question. So when you're doing the animations,
yes.
Is the JBox body also are the values of the JBox body also changing?
No, in this case, I'm doing it actually. There is this bird that you see there is not in the world yet. So it's actually a fake. It's just an illusion.
Add it when you toss it?
Exactly. That's the trick here. So. We have our bird here, and then I use mouse events, and I drag it so it leans back, and it flies, and you can see now it's the actual World 2D body, and it rotates, and well, the level is reset. So it zooms back, and as you can see, when it's flying, the camera is following it, and this is a nice effect. And I've implemented this in the level. This is basically the base class. Oh, where am I doing it? Yes. No. Oh yeah, there's another thing that I'm doing. You saw the score up there. There was a score label. And the score label is not supposed to move with the scene. So what I'm doing is I'm using this binding API to add a change listener to the score property. So we've got these properties in JavaFX, and you can listen for changes to properties. That's a very nice pattern. Actually, there are a lot of people who want this to be part of standard Java, so it can be used anywhere. So we've got this score. I add a listener, and no, it's the translate property up here. I add a listener to it, and whenever the scene, the main panel translates, so when I move around, I set the translate to the negative value of what I get. And it works pretty nice. I was expecting to see some flickering or something, but if you have a look, it really stays solid in the position. And I also bind the values here. So here I've got, this is just a regular JavaFX label. And here, down here, I've got a score property, which is just a simple number property. And when I hit something, when there's a collision detected, I increase the score. And I don't have to do anything. I don't have to add listeners or so. The only thing is I have to listen to the score property. When it changes, I get the value and I display it on the score label. That's really very nice. That's very nice to implement with JavaFX. And okay. Okay, let me see. So the next thing that I'm doing in here is I have to detect the collisions. So I have to find out when the bodies collide, and I have to decide whether I should explode them or remove them. So that is also very easy, because there is the contact listener class, and the contact listener class allows you to register on this world, and whenever a collision occurs, it will inform you. And I've simplified this code a little bit here, but it's like a couple of lines longer. It doesn't fit on the slide. There's one method that is important, and that is post-solve. And in post-solve, you get the impulse. And you get the bodies here, and you can ask, you can loop through the impulses and, that you get, and you can find the maximum impulse, and you can check if it exceeds a certain threshold. And if it exceeds that threshold, I will say the body should crash. It should explode. It should be removed. Removing is not very easy, actually. It was hard to find out. And this threshold is something that that is very important for that your gameplay feels nice. But you have to really find out by trial and error what is the right value. We have to play around here. So when I want to destroy a body, I actually register it for destruction. Because the world, it's again like, we are Java developers and we are living in a very nice world, because most of the APIs we are working with are really good. And for example, here there's a method in the world, and that is destroy body, I think. Yeah, destroy body, it's called. And you think you can just call it and the body will be destroyed and removed, but that isn't true. It only works if you do it inside the step. Inside the one step of the simulation, after one step of the simulation is over, and before the next one has started. So what you need to do is you need to create your own world class. You need to extend world and override the step method, and then you can take your bodies that are registered for destruction, and you can destroy them. And you can tell the view that it should also remove the body. And then you can, then you clear the list where you stored it. At least that's how I'm doing it. One other important thing to know about, you heard about the bodies and the shapes in Box2D, but there are also joints. And those joints make it possible to have these like these strand beasts that I've shown you. The strand beast is using motors and revolute joint, distance joints. A distance joint, this is for example a distance joint. A distance joint is created by creating a body, or actually creating two bodies and connecting them via a line. So it's almost like a rope, but it's more like a pole that keeps them at the same distance. I will show you in the Box2D project, JBox2D support. That's the easiest way. So I will create a new template, a new file from a template, and I think it already has one body predefined, so we can reuse that. And no, Okay. I will create a new body. And I think somewhere here, probably this one is, yes. So I created a distance joint now. And when I simulate the world, yeah, it should dangle here. So you can see the movement of this body. Actually, this one is, I think it's fixed rotation. That's why it's not moving around. Probably I should zoom in a little bit. Okay. And I will create another body. There you go. Actually, I wanted to do a revolute joint. A revolute joint is, well, it's a bug in here that you always keep the tool that is selected up here. But a revolute joint would be when they overlap and you make like a hinge, I think you call it, right? Okay, so it dangles around one hinge. Okay, so in my project, basically when you create your levels or your game, you import your assets, you create your bodies, you save your world, you simulate it, you play around with density and friction, and you very, very soon will get something that is really playable. Like, for example, the game that I created is like, I don't know how many lines of code. It's really not very much. So you can see here, this is just the main class that will launch the game. It's just, it adds in the main scene, the level board that we have here. The level board displays these buttons that you can click and start a level. And the most important part is the level here. And you can see it's like, well, 320 lines of code, and that is basically where the whole game is developed. So what you can see here is what I'm using for deleting the bodies. That's the explosion. So I pass in a position actually, and I create a couple of particles at random locations with random speeds, and I let them spread. So I don't know if you saw this little animation when it explodes, when something explodes. And I create a timeline for it and run it. And after a while, these particles are faded out with a fade transition. That's also something very handy. And as you can see, those 300 lines of code are actually not a fake. There are lots of empty lines in here. So you have this fade transition, and it creates this effect here. To restart. I should add a button to go back to the level board. As you can see, this is work in progress. I actually finished, I rewrote the engine a little bit, and I only finished this yesterday. I have to go to level 2. So, and have a close look when the bird collides. You saw these little gray icons. That is the translate transition and this explosion, also done with the timeline. I was actually expecting, with all these transitions and animations in there, that the system would somehow slow down, or that it would put a lot of load on the system to do stuff like that. But it's actually I do not have to optimize anything. There are no performance drags or something. It's really very, very powerful as a system. So from this base class that you've seen, you can extend. And we will do that, and we will create our own level. The last thing I would like to show you in here is the function that you use to actually launch the bird here. And what I'm doing is I'm stopping the simulation for a second, and I find out what force is used, so how far the user has dragged the node and the angle that I should launch the bird. And then I use my, my regular builder to create a circular shape. And that's a circular shape because I'm lazy. It should be a polygon. It's much nicer if the bird doesn't roll so far. But I add the string bird as the user data, and that is used in the mapping in the world view to find the correct node for it. I set linear velocity on the bird, so it gets an impulse, so it is launched, and it has with a certain force. And then I ask the view to play again. So I start the simulation again and let the world do its magic. And what I'm also doing here is I start another timeline, so the game doesn't go on forever, or I don't want to wait until all the bodies settle down because it takes too long. So what I'm doing is I tell the system that after a certain amount of time it should simply reset the scene. So in this case it's 8 seconds. So after 8 seconds I'm stopping the view again, calling the init method. The init method will set up all the nodes, the base nodes, and it will create the initial world for us. And then I'll call play, and the game will continue. So I've prepared one empty level. And well, level is abstract class. And there's one, at least I thought it is. Let me check. Yes, it is. It has a method create bodies that you need to override. And this is where you create your own world, and you create your assets. So let's create a new box that we can shoot at. It will be a dynamic box. We have to position it. I have to look up where actually the floor is. So a good position is obviously here. So let's see. Okay, good, like .1f, and give it a density and build. Let's see. Okay. Let's see what we've got. There should be a dynamic body somewhere. Oh, The demo gods. Okay, obviously I did something wrong. So let me check. Okay, these are the bounding boxes actually. So the position was probably wrong that I had here. Ah, okay, I know what happened. There's no floor. These things here that I create are the floor and the bounding boxes, and they are missing. So everything is falling down, and that's why everything is screwed up. So what I'm creating here is simply boxes, and what I did is, for convenience, I added in a string that is hidden, and whenever it's hidden, I don't want the node to be displayed actually. It's there, but it's not displayed. So we have the body now, we have the world now, the environment. And I've created actually a method that you can use to create these blocks, and these blocks are image have an image attached to them. So I just have to tell the system where they should create it and if it should be rotated, and if it should be rotated to what angle. So I call this method make one. We can have a look here. So it's just calling a regular box builder again. It creates a box of a certain size. And what I pass in here is an image, a string that here defines my resource. And well, then I position it, set the width and height, so an angle and totally irregular stuff. So let's go back. So now I created one box, and I hope this time it works. Okay, so here we've got our box, and we can shoot at it. Oh, missed it. Okay. So I encourage you to play around with JavaFX and Box2D. It's a whole lot of fun, and it really, well, I enjoy it a lot, and I enjoy a lot working with JavaFX. And I hear a lot of people here at Java 1, and I discuss with them, where is JavaFX? Is it there? How are the controls? Why is there no formatted text field? And stuff like that. And I get very different opinions. Most of them say like, oh, we will have to wait. We'll have to see if it will pick up. In my opinion, JavaFX is going to stay, because it's going to be part of Java. So I will use it, and I'm using it for playing around. And one thing that I think is very, very important, a very important thing to say about a technology is it's really fun to play with it. It's really, you really enjoy to work with it. So I encourage you to play with this. And here are some resources that you can use to learn more, especially for creating games. This one is an Italian programmer, and she's got a blog, and she's fantastic. It's really on this blog, every few days you see a new article popping up. She's creating Flash games, but she's using Box2D, and all the stuff that she does really applies one by one to what you can do. So the code is very readable, the code examples can be transferred very easily. One other resource that is very important is the Box2D manual. This is not for JBox2D, but for Box2D, but it explains everything in great detail, how the bodies work, how the joints work, how you can build more complex vehicles and stuff. And there's jbox2d.org, where there are forums and where you can download the stuff. The project itself, JBox2D, is on GitHub, I think, or Google Code. I'm not sure. So, but it's linked here. So you can get the latest sources from there, and you can play with it. I'm actually trying to put in some extensions there, especially the builders, because it's much easier to program if you have builders available. And I also try to contribute my persistence, my XML persistence for NetBeans, because this persistence format would be fantastic. You could even use it in Android, or you can use it in other worlds. The persistence format that they are using is based on what's it called? It's a Google project. Google some kind of protocol buffer, I think it's called Google Protocol Buffer. But there are a couple of things I don't like about that, and one of them is with XML you can very easily create an editor that you can with code completion and syntax highlighting and code folding and stuff. So you can actually have a look at the code, at the generated worlds, at the persisted worlds, and I'm using NetBeans to create the editor for this. It's really very, very simple. And the other thing is that in its current state, it doesn't support, for example, chain shape and some of the shapes that I need for creating my pinball worlds and stuff like that. So I would rather go with XML here. So the XML format I'm using is not perfect, and it's also still work in progress. The whole project that I show here is not very old. But I will continue to work with it, and if there are guys here who would like to help, you're welcome. And you get a t-shirt. And you can get, you can find the slides. I will upload them on my blog on jskills.com. The project that I've shown you are the JBox2D support is on GitHub, and also the JFX box2D, where the worldview is also on GitHub. It's not much there, but it's you really don't need much to create a little game. And yeah, it's time for questions. I'm very quick. You get a lot of time for questions, actually. So I encourage you. Thank you. Sorry?
Where do you have like the background images and the images?
That's in the level, I think, at least. Let me check. Yeah, the background is an interesting story. What I wanted to do is, I've got this style sheet here, and in a style sheet you can set the background for JavaFX, for JavaFX nodes and parents. But I had a problem. Actually, it would probably work if I would use it again now. But I had a problem because in my development version, the scene would also zoom in when the bird node would just reach a certain height, so you cannot see it. So you can always see the bird node. And in that case, and also when I'm translating, the background would vanish. So it would only show for the initial screen. So what I did was I created a couple of image views and added those. It's not something I'm proud of. I think there must be nicer ways to do that. Probably I could use a canvas and simply draw everything into a canvas and use that as a background. But it works. So this is how I'm doing the background. Wait. Who was that? Who did ask the question? Was you? Okay. Which one do you want? From Atlassian gave me only very, very strange sizes.
That's what you got. That'll do.
Okay.
Thanks.
How
Sorry?
does
I remember you. No, I have not tried yet. I'm sorry. But I will. I should try that. Cool. Oh, wait. You get a t-shirt. So do you want the blue one, or, well, you can use it as for at night because it's way too big for you. Another question? Okay.
You may have shown it, but how do you detect the collisions?
Ah, sorry. Okay. I've shown it in the slides, but I didn't show it in the code. Wait a minute. The collision is detected. No. There's a contact listener class that you use. Exactly here. The contact listener class has a couple of methods. I'm only using the post solve, it's called, I think. Yes. And I will get informed whenever there's a collision. And what I'm trying to get out of this collision is who is colliding, so I can ask it for the body. And what I'm trying to find out is the power, actually, is the impulse. And if this impulse exceeds a certain threshold, I schedule the body for destruction. Okay. Wait. I'll go around with the bag, I guess. Okay. Let's see. I've got. I don't know what size this is. Is it okay? This is.
Oh, that's perfect.
Okay.
Yep. Thank you.
Cool.
Can you show where you calculated the angle and the velocity?
Okay. Just wait. I didn't do that before, but that's very good for getting questions. So I'm doing this in the Aaron node, I think. Yeah, here. So when the mouse is pressed, I'm getting the layout X and the mouse X. And when the mouse is dragged, I'm first calculating the distances. And so here I get the distance. And from the distance Y and distance X, I can get the angle. Did you get your shirt already? Okay. Okay.
How hard would it be to like those two worlds and then be able to ship?
Sorry, I didn't fully get that. How hard would it be to?
To create like two different worlds that you can ship between. Like if you want to do a scene from going here and then ship to another scene, but maintain the persistent state of the scene.
Well, I can do that. There's actually nothing involved in that. It actually works when I could like just do a back button and switch back to the level board. And if I store the level, if I don't reinitialize it, you mean persisted between two sessions? So when I stop.
So like go one level and then go to a different level and go back to your original level.
Okay, what you can do is like just keep the object in memory. Then it will keep the state. Yeah, but that is there's actually nothing to it. So if you like hit a certain node, so you want to bring up another scene, is that what you would like? Okay. Well, you add a contact listener, and from the contact listener, you just tell the system to display another scene. You do not even have to persist because those scenes that I'm using don't have many objects, so you can keep them in memory for a huge game. Okay.
Do you create each individual character using Photoshop? How do you create?
I can show you. I created them using. I don't think I have. I still have one. I think I have no. Do you want to exchange? No, I only have extra XXL. Sorry, that's all I have. Sorry, I can show you. Well, actually, I'm using some. I'm using GIMP, and I get these assets here. So there's a lot of room for other stuff, but this is the important one. So what I'm doing is, I'm really for this one, and this is the way to go, is I'm putting all of them in one PNG, and then I have a class that simply copies a portion to the image view and displays it. So there's basically an animation going on that cuts out a part from the image and displays it. That's in the, if you want to see that, that's in the Worldview project that I uploaded today. Okay. Sorry, you were asking for. Okay.
Is there a 3D box, or do we have to make?
No, this is all of that is 2D. I'm sorry.
So I guess with 3D simulator, we can emulate production plans and data 3D.
Well, if you're limited but you can create. Well, you can simulate a 2D world, and you can display it in 3D, but you're limited in a way that it's still going to be flat. There's no way of. I'm not sure who was the next one to ask, but I.
Currently calling step after you abstracted that away.
Sorry?
Where are you currently calling step after you abstracted that away? Because before you had step being called in a loop.
Okay. I'm doing that via timeline. Is this okay? I'm doing it timeline. There's JavaFX has the timeline animation, and at the end of a keyframe, I get an event, and then I'm calling step.
Did you try to add sounds?
To add?
To add sounds?
Sounds. Yeah, I did that in another game. I can actually show you. I think I've got it, but you will probably not hear it anyway. I'll go closer with my mic. So let me see. Where is it? Here. But it's hard to get good game sounds, so that's why. So you will have to wait until I actually finish one line to see to hear sound play. So do you know the Tetris gods? The gods of Tetris? It's a very... Oh, did you hear that? Impressive, isn't it? Okay.
Do you have any experience in making multiplayer games for JavaFX?
Multiplayer games? No. I'm sorry. What I wanted to do actually with this Tetris game, I wanted to use there is, I think it's called Project Darkstar, and with Project Darkstar you can have like a game server, and with this the level increased, and you can connect to it, and you can have multiplayer games. And I wanted to have it like via the internet, so you can play against each other, but I did never implement it. Oh, well, you just have to play the sound at the when you.
Say I want to like the bird,
Yeah.
Or chicken, right? So
yeah.
How do you really make that in a way that it really looks in FX?
Do you play with the image more, or do you try to?
I'm not sure if I fully got the question.
No, the thing here is, okay, so I have an image.
Yeah.
It's like the bird
Okay.
making sounds, right? So I want to simulate exactly like how the bird.
Oh, okay. When it's, for example, when it's flapping its wings or so.
How do you really blend that into the code?
Okay, you have keyframes, and you can use keyframe animations, and then at the certain keyframes, when you switch the image, you can also play the sound. That is that way you can really very nicely synchronize between those two.
I came in late, so I apologize if you already covered this, but why do you stop the animation when you do your calculations? And can't that potentially cause like a little jittery animation?
At what points? At what?
Near the end, you were saying you do a view dot stop.
Yeah.
And then you'll do some calculation, and you do
okay.
and can't that potentially cause a
no, because the scene itself is not affected from this. It's just a simulation in the background that is affected, and it will stop for a very short amount of time. Okay, I think I'm almost out of shirts now. Oh, actually. Okay, she left. I've got one small. Okay.
Do you have like forces between bodies, or like gravity between bodies and stuff like that? You know,
Yes, you have that.
I already got one.
Yeah. Okay. Sorry. So it's actually a question. That's a good question then. That's not for getting a T-shirt. Yes, you can do that. You can have some. You can distort gravity. So partially, and you can also. There are some tricks that you can do to have like radial gravity. So you don't have like usually the gravity vector is just one direction over there.
Like the new
yeah.
Angry Bird space.
Yeah, you can do that. And actually, the
minutes and you try to like hit the things on
exactly.
When you get close to them, you get pulled in, and it's really
exactly. And it's also on this blog that I pointed out from this girl. She has a blog entry about exactly that, how you can do that. These are reserved, so I have to keep those. But if you still have questions, I can.
Yeah, I wrote my own mini physics engine. And,
cool.
And I did like gravity and repulsion and all that. So I'm just curious, I probably missed this earlier. How did you map how are you mapping JavaFX nodes to the animation? Because I don't know, I'm just curious how you did it.
Okay, what I'm doing is, well, there are two ways of doing that. One of them is you can create a map in the view. That's what I did. And the other way is like a lot of Box2D guys are doing it like they use the node as the payload of the body. So you have bodies that use the data, and they just add the node there when it's first rendered, and next time they get it out of the node. But the problem with that is that it's not generic solution.
Yeah, I think the generics.
Mm-hmm.
These are different stuff. Okay,
Cool.
I didn't see that earlier.
Mm-hmm. Okay.
My question is actually referring to the earlier question with the two parallel worlds
Okay.
running at the same time. Is it possible to use Box2D?
Can you wait a second? I would like to talk to you. I want to find out about your project. Okay.
Is it possible to use the Box2D word computing in two separate threads?
To use the same box in two separate worlds, or
Is it possible to use multi-threading on Box2D?
actually, I haven't played with it, and I haven't investigated it. I'm sorry. I don't know. Okay.
Found any performance limitations on using
No.
physics?
So far, it's actually running too fast. So when I'm thinking about how to slow it down, because the bird is flying too fast. When you compare it to Angry Birds, in Angry Birds the bird is much slower. So it's way too fast. I'm probably doing it via the timeline, slow it down a little bit. But it's absolutely no limitations I've seen this so far.
Well, part of the reason why I asked that question before is I've also seen people use, I think it's called like animation timer or something like
Mhm.
that, to in the override that tick method. So
Yeah.
that they get a constant
Yeah.
number of ticks per second.
Mhm.
Try and prevent like that.
Yeah, I'm actually doing that as well.
Okay.
Yeah. So I can slow it down, but I actually, as I said, I finished this version of the game yesterday evening, and it's ongoing work. So there's a lot of polishing going on. Next thing I'm planning right now, my builders are, for example, only creating. You have a box builder, and that is actually something stupid because you can attach multiple shapes to one body. So there should be a body builder, and after that a shape builder. That will change in the project, but it's very usable actually, like this. And I found the most glitches I found actually were in JavaFX and calculating the positions. That is really very hard because you have. That is the only thing that I'm really fighting with in a lot in JavaFX, because you have these layout bounds and you have the bounds in parent and you've got the local bounds. And it's not very clear how they are calculated because it really depends on in which parent container you are. And there's one tool that you can use to debug the scenes, and I think it's called Scenic View or so. And if you have a look at Scenic View and you put the same object, the same node in two different containers, the bounds of your object will change. It will totally change, and in a for me unpredictable way. I didn't find a pattern to this yet. Okay.
General question: how can I run a project using Eclipse? Can Eclipse simulate it?
If you have to use Eclipse, then well, it's just a couple of lines of code. Basically, it's if Eclipse doesn't run it, just copy them out and create your own project from it. But it's an AND-based project, so it should there should probably be support in Eclipse as well.
Can this program run on iOS platform?
No.
Android?
Android, this one not, because it's JavaFX, but JBox2D is running on Android. It's actually what on the Android version of Angry Birds, JBox2D is used.
I think there is an iOS JBox implementation.
Yeah, there's a Box2D implementation for, but it's not JBox2D. Maybe there's Box2D for iOS. That's where it first thrived, actually.
Or you can use Box2D.
Mm-hmm.
Because it's a C library.
Yeah. And if you want to do that, again, well, she's creating Flash games. That's also probably nothing for the iOS.
They do have Box2D for iOS, though.
Sorry?
They do have Box2D for iOS.
Yes.
Is it possible to change dynamically the shape to make deformation in the
Yeah, there are ways of doing that, but it's not possible with one shape. But you have to combine the shapes, and you have to use different shapes, and you have to use joints between the shapes. For example, if you want to have a blob or something, that really creates.
The shapes are immutable objects.
The world cannot deal with it. What you always can do is like you can remove a body and replace it with another one and copy the impulse and air forces. That should not be a big problem actually. Okay.
You actually brought it up, and now I'm actually really interested in how your debugging of how you combine JavaFX and Box2D. Like, I in my mind, I would see that be a problem trying to debug JavaFX when you're trying to draw it on the scene, or like on having parents, trying to compute the boundary and draw it on.
Yeah, but if the way I do it, it's extremely simple. I just the nodes are actually where the position is, and that there's not much translation going on. The only thing is I'm translating the scene, and that is something that is easy.
Just have a parent, which is the top level node, and just add an image view.
Yeah, exactly. So it's easy to debug, no problem. Okay, no more questions? Thank you. Okay. If you have a USB key, I can also give you the presentation. Do you have USB stick? No. Okay. Hi.
Fine. I came to watch your presentation because last month I published a game on the Android market, so I was thinking if I can port it to JavaFX, so it's like...
Is it using Box2D?
No, I wrote a small collision engine, so it's like a race between fruits and vegetables. So I was thinking if I can also port it to...
That's probably very easy to port.
Yeah, so it's just, I have like a small MVC, so the model alone and drawing alone, so I was thinking...
It's probably very easy to do that. And it's really fun to do that.
Yeah.
I don't want to keep you from going somewhere. I just want to jot down your name and your maybe.
My name is Emilio.
Okay. And the name of the project, because I want to look it up.
Can you put that slide back up with your website and the GitHub?
Okay, I will try. Otherwise.
Go ahead and send me an email. I'll send you information.
Thank you very much.
Yeah.
Let me see. Oh, slide. This one?
That's it. Thank you.
The presentation.
Ah, cool. They all look the same. I got this very new, and the strange thing is yesterday I wanted to connect it to the network. Oh yeah, there was something. It doesn't have a network connector. Just let me see where it is. So this should be it.
It doesn't have one over here?
No. You have to have an adapter.
Must be like a newer model. Thanks.
Yeah. Okay.
I forgot my USB.
Okay.
I need the last slide.
Okay. I'll put it up again. You should go to the demo grounds. There's one spinning wheel, and if you answer the question, also if you don't answer the question, you get a USB key. Just a tip.
Be interested in doing some testing or helping out. I wrote some stuff with Box2D and JavaFX already.
Cool.
I've been working on a game for my son, like a side scroller.
Ah, nice.
You know what I mean? Like a side scroller.
Yeah, sure. I know the side scrollers.
Cheap.
Cool.
But, that's me.
Excellent. Yeah, I'm always interested in but I have to write it down because, with the side scroller. Thank you.